All right, so I'm showing here that it's odd. So this is 4 minus x squared. And then you see we just have that negative out in front of it. So this is just negative f of x. So f is odd. And since our function is being integrated from -2 to +2, same on the left side of the y-axis as the right side of the axis, that means this integral then is just going to end up being 0. All right, because it's odd and because our limits of integration are symmetric about the y-axis, we get 0. So we don't have to do anything. You could go through and do it if you want, but you will end up with 0. You could do u substitution, u equals 4 minus x squared and do it, but you'll get 0. Okay, but you should probably still try it if you didn't, just to convince yourself. All right, so next, how do we find the area between curves? Well, essentially, all we're going to do is subtract one from the other. So if I looked at something like this, like say I had this curve here, and then I had this other curve down here. If I went and found the area under this first curve, it would be this. And then if I went along and subtracted the area from the second curve like that, I would just right then have the area between them, right? And I don't know what you're thinking, well, what if one of them goes below the x-axis, or they both do? Well, that's not going to matter, because even if they go down here below this x-axis, say that one goes below the x-axis, this part down here will be negative, but we'll just be subtracting a negative. And so it'll just get, so instead of finding just this area right here, we'd get this area up here plus this area below. You see what I'm saying? It would become a plus. And so we'd still be getting the area between. So it's going to work above or below the x-axis. And so that means that we can find this area between, if we just do the integral from a to b, the same boundary for both of them, of the upper one minus the lower one. Okay? And that'll give us the area in between. Simple as that. Which means you could also just do the integral of f of x and then minus the integral of g of x, but right, from our integration rules where we could split that up into two integrals, which would kind of fit with what I was telling you down there below in that wonderfully drawn picture. Okay. All right, so let's try some. Find the area of the region bounded above the curve y equals 2e to the negative x plus x, and below the curve y equals 1/2 x. Okay, where's my picture here? There should be a little picture of it. Where is it? That's weird. Okay, I don't know what happened to that picture. It was there last time because it's here on my notes where I printed out for myself. So I don't know what's going on there. But anyway, we'll draw it real quick. So our graph is going to look something like this, and then this kind of a thing. We're going from 0 out to 1, right? And then this is at 0.5, and this up here is at 2. Okay? And so it's bounded below by this is the y equals 1/2 e to the x. And this is the y equals 2e to the negative x plus x. There you go. Okay. So there we see our graph, and we're looking for this area right in here. Okay. That's what we're looking for. And so we're going to just do this integral. We're going to do integral from 0 to 1 of 2e to the negative x plus x. That's our first function. All right. Minus our second function, 1/2 e to the x. And then this whole thing times dx. There we go. And so we can integrate each one of those individual terms by itself. If I go to integrate 2e to the negative x, what is that going to become? Yeah. Negative 2e to the negative x, because the derivative of this would be, right, if we did the derivative d dx of negative 2e to the negative x, the negative 2 just stays. And then we do e to the negative x is just e to the negative x. And then it's times the derivative of negative x, which is negative 1, right? And so it's just e to the negative, it's 2e to the negative x, right? So that works just fine. Then for the next one, the derivative of what gives us x? Right? Add 1 to that exponent and then divide it by the new exponent, x squared over 2. So the derivative of x squared would be 2x, and it's divided by 2, so it's just x. And now we have 1/2 e to the x. Well, that's easy. 1/2 e to the x, right? That one's super easy. And this whole thing evaluated from 0 to 1. So we come along here and we start plugging in 1 first. So this is negative 2e to the negative 1. This is 1 squared, so it's 1/2. And then this is minus e over 2, because it's e to the first. And then that's the 1. And then we do minus it, all this to the 0, putting 0 in there. Negative 2e to the 0 plus 0 over 2 is 0 minus 1/2 e to the 0. And so e's to the 0, anything to the 0 is what? 1. So that guy's a 1. This one's a 1. And so what we end up with is, this is negative 2 over e plus 1/2 minus e over 2. And then we get minus a negative 2, so it becomes a plus 2. And then minus a 1/2 becomes a plus 1/2, right? Distribute that minus sign all the way through. And then you go through and you start doing this. You have a 1/2, and a 2. So that's 3 minus 2 over e minus e over 2 equals, just, real quick here in my head, it's about 0.9051. So somewhere around there. And that's it. And if you got a negative answer, you probably did something wrong and you need to go back, right? Like if you had done, if you had done 1/2 e to the x minus the other one, if you had flip-flopped them. So be careful you don't get a negative answer doing this. Okay? Good? All right, I think all we have left is to do some examples, so let's go, let's do them. No questions on this one? I like questions, so please ask me. Okay. Here, find the area of the region enclosed by the parabola y equals 2 minus x squared and the line y equals negative x. So we'll start off by drawing this to help us see it. So when we draw this, who can tell me what is 2 minus x squared? What does that look like? So close, up 2, but not U-shaped, upside down, because it's that minus x squared. So good. So that's going to be something that does this and does like that, right? And that's at 1, 2. And then what about y equals negative x? Any negative slope I want? So like that. So this is 2 minus x squared. This is negative x. And then where do they meet? We need to find this point and this point. How do we find where they meet? set them equal to each other, right? And so when we do that, we get negative x equals 2 minus x squared, right? And then that becomes x squared minus x minus 2 equals 0. Can we factor that? Okay, what is it? Did you say x? What's this one you said? Plus 1. Okay, just making sure. Equals 0. That's good. And so x equals 2 and negative 1. So if we plug in negative 1 to either one of them, we get 1. So this is the point negative 1, 1. And if we plug in 2, we get 2, negative 2 for either one. Okay, so those are our 2 points. That means our limits of integration have to be from negative 1 to 2, right? So now we need to actually do the integral. So that was our first part here. So now we do the integral from negative 1 to 2. And what do I want to put in here? Which one do I write first?
2 minus x squared.
There you go. 2 minus x squared, and then minus the other one, right? So like that. It's on top. Yeah. If we were looking over here, let's say, like say they said find the area between them from negative 3 to negative 1, then we would have done it the other way. But we're looking for this area in here. Look at that, shaded it in perfectly. Really good at staying in the lines, huh? I know, it's impressive. It's impressive the way I didn't go outside the lines down there on the bottom part of it. Okay, this is awesome. I'm recording this class and all my bad attempts at humor are getting recorded here, so. Okay. So now we go through and integrate it. So I'm going to let y'all give that a try. Right, I'll rewrite it one more time here as 2 minus x squared plus x dx. And do the integration there. Go ahead and try it and see what you get. And I'll pause this. All right, so there we integrated it. 2 became 2x, negative x squared became negative x cubed over 3, and x became x squared over 2. Evaluated from negative 1 to 2. And so we'll plug numbers in here. So let's start with the 2. So this is 2 times 2 minus 2 cubed over 3 plus 2 squared over 2 minus, and now we plug in the negatives, right? So minus 2 times negative 1 minus 2, oh, not 2, negative 1 cubed over 3 plus negative 1 squared over 2, just like that. And so 2 times 2 is 4. This is 8/3, and 4 over 2 is just 2. And then minus negative 2 is plus 2. Negative 1 cubed is negative 1. So that's a plus 1/3. So it's a minus 1/3 then from this minus sign over here, right? And then negative 1 squared is just 1. So that becomes minus 1/2. Common denominator we can do here, I guess, is 6, right? So this is 24 over 6 minus 16 over 6 plus, what am I doing here? 12 over 6. What? It's minus 1/2. I hope I'm right. Please check me on these. Don't let me make a little algebra mistake. So 12 over 6, 12 over 6. I probably could have combined a couple of these first, right? minus 2/6 minus 3/6, right? And so 24 minus 16 is 8, plus 12 is 20, plus 12 is 32, minus 2 is 30, plus that is 27. Is that right? 27/6, which we can reduce down to 9/2, dividing everything by 3, right? Which is the 4.5. Any questions on that? We're okay on that? Okay, good. So go ahead and try this one. I'm going to let you draw the picture and you try the whole thing here. So we'll pause. I'll give you, what time is it now? So for this one, we had to do 2 sections there. One to find this area here that's in blue that's in that first quadrant. So we had to do, oh no, I have it on erase. So I had to do this section over here is just the area underneath square root of x. And so that'll be that integral from 0 to 2. And then I have to do this one over here, which is between the 2 functions, and that's from 2 to 4, and that's this one right here. All right, and so I'll leave that for y'all to try, and you should get, you know, ultimately equals 10/3. If we go to the next one, it asks us to do the same one, but as a function of y. And this should make it a little easier. If you switch everything over to a function of y instead of a function of x, what's going to happen is you're going to find that same area, right? It's this same area here, but this time we don't have to break it up because it's just the area between those functions that would still be in between there, right? So you would do, you know, whatever this function became, you'd solve it for a function of x or for a function of y, right? And then what this one became, so minus that one. That makes sense? So we would do y equals square root of x, and it would become x equals y squared, right? A parabola. And then this other one, we've got y equals x minus 2 becomes x equals y plus 2. And that would be that straight line. And so your integral here would be from 0 out to 2, because that's the value there on y. So 0 to 2 of y plus 2 minus y squared dy. And that's the integral you would want to solve there from 0 to 2. And then you should get that same 10/3 of an answer again. Okay? And then on this very last one, just let's calculate the area between them. So you could, I guess, try it again. Any other method you could think of? Yeah. Yeah. Well, you could do the area underneath the parabola and then do it geometrically. So if you look at this picture, if we paste this in here, you could do, here's what I was thinking, what I did here, you could do, is you could do the total area underneath the square root of x one, do this total area here, right? And then go back and find the area of this triangle here, just using the triangle equation, and subtract that triangle off of it. And that should also give you 10/3. So 1 integral minus the 1/2 base times height of that one. Okay, so try to finish off all 3 of those. You should get 10/3 for each of them. And that's pretty much it for that.